Okay, today we're going to start our notes on similarity. Yes, that's the new baby, Mark Gregory Yem. Week ago is when he was born. So today we're going to start our notes on our new unit. And it looks like this. It's on similarity. So as always, we need to learn a little bit of the basics and vocab before we get started on a new unit. So that's what we're going to do. So today we're going to talk about ratios. Okay, a ratio is a comparison. So when we're looking at, say, the number of boys to girls in the classroom, we're comparing how many boys to how many girls, or how many blue-eyed people to how many brown-eyed people, just strange examples. So when A and B are two numbers, and B does not equal 0, we could write our ratio like this: number of boys over number of girls, like a fraction, or we could write it this way, side by side, boys to girls. Number of apples to bananas could be written number of apples to bananas, means the same thing. So we're going to talk about how would we write this. 24 yards to 3 yards. First thing I do is check and make sure I'm talking about the same unit. Yes, they're both yards, so I could compare 24 over 3. Now if I notice, I can reduce this fraction because 3 does go into 24 8 times. So 24 to 3 yards, comparing that, is a ratio of 8 to 1. Or I could write it this way, 8 to 1. But we want to be careful and try to reduce all of our fractions or all of our ratios. Now let's look at the next one. This is a little bit different because the top says centimeters and the bottom says meters. Now if you remember from learning about the metric system, 1 meter equals 100 centimeters. Like on a meter stick, it's 1 meter long, but there's 100 little centimeters on it. So I can change this bottom because if 1 meter equals 600, 6 meters would equal 600 centimeters. Okay, so 150 centimeters over 600 centimeters. Now I have the same unit, centimeters and centimeters. And when I reduce this, because 150 goes into 600, and it goes in there 4 times. So the ratio is the same as 1 over 4. 150 over 600 reduces to 1 over 4, so they're the same thing. I could also write it 1 to 4, top to bottom. And I guess I didn't emphasize that over here. Top, then bottom. Okay? And so if it says 24 to 3 yards, the 24 goes on top, the 3 on the bottom. It's already set up here for me. Okay, let's look at the next one. Now this one talks about the perimeter of a rectangular room is 48 feet, so I'm going to give it a circle. And the ratio of its length to the width. So length to the width is 7 to 5. That does not mean that the room has a length of 7 and a width of 5. It just means that's how they compare to each other, the length to the width. Now I know for a rectangle, the perimeter equals 2 lengths plus 2 widths. Okay? So in our case, our perimeter is 48, and the length has a ratio of 7 to 5, so I'm going to say 7 times some number, I don't know what it is, I'll find out later, plus 2 of the widths, and the width has an extended ratio of 5, so I'm going to put 5 times that same number that I multiplied times 7. Now when I go ahead and multiply out, 2 times 7x is 14x, and 2 times 5x is 10x. When I combine my like terms, because these are both x's, I get 14 plus 10, 24x. And then when I divide both sides by 24 to get x by itself, I find out, hey, x equals 2. Does that answer my question? No, the length of the room is not 2, the width is not 2, but I do know I'm going to plug it right into this equation here. I do know the length equals 7 times a number, and I do know the width equals 5 times that number, and that number is the number that I found. So the length equals 7 times 2, which is 14 feet, and the width equals 5 times 2, or 10 feet. Now if I want to, I could go ahead and check it in here. 2 times 14 plus 2 times 10, yep, it equals 48. Okay, so now we're going to do something called extended ratios. Remember that the measures of the angles in a triangle equal 180 degrees. Okay, that's never going to change. Doesn't matter what kind of triangle it is. We've learned that in the last couple of chapters. Actually, we reviewed it in polygons on the first day. The extended ratio of the angles, now remember, they're talking about the angles, is 1 to 2 to 3. That's how they compare to each other, but we don't know what we're multiplying. It can't be that it's 1 degree, 2 degree, and 3 degrees, because that doesn't add up to 180. But what I do know is 1 times a number plus 2 times that same number plus 3 times that same number is going to give me the sum of 180. Now when I combine my 3 terms, I get 6 of those x's, which equal 180. And when I divide by 6 on both sides, I'll get x by itself, and it equals 30. Is that the measure of an angle? Well, let's see. One angle is 1 times 30, so 1x equals 30. So there's one angle. That's this one. The next angle is 2x, so 2 times 30 is 60. And the third angle is 3x, or 3 times 30, which equals 90. So of course, if I were to draw that picture, which they did ask me to make a sketch, there's my 90-degree angle, here's my 30, and here's my 60. Okay, let's go on to the next one. I'll change color so we can see the difference here. Very similar problem. The measures of the angles of the triangle are in the extended ratio of 1 to 3 to 5 this time. So I know that 1 times a number plus 3 times that same number plus 5 times that same number all will add up to 180 degrees. 1 plus 3 plus 5 is 9 times x, which equals 180. And when I divide by 9, x equals 20. Does an angle equal 20? Let's see. 1x, 3x, 5x. So 1x equals 1 times 20, 20 degrees. 3x equals 3 times 20, or 60 degrees. And 5x is our third, our largest angle, which is 5 times 20, or 100 degrees. Do they add up to 180? Yep. Just checking. Now this triangle would have to be somewhat obtuse. Maybe I made that too obtuse, too big there, because my 100-degree angle is bigger than a right angle. Then I've got maybe my little angle here and my other angle over here. That's extended ratios, it's called. Okay, now let's talk about proportions. Okay, we're more than halfway done. A proportion, and you can run into these in science class, all kinds of tests have proportions, in equations with two ratios that are equal. In other words, you have two equal fractions. That's what a ratio almost always will look like. Whenever that happens, we use the cross product property. To solve a proportion, you multiply across and solve for the variable. I think maybe you remember doing this in middle school or grade school. I've heard people talk about this fish symbol. Top here times bottom here, top of this fraction times the bottom over here. So here's our ratio that we're looking at. M over A equals B over R. So using the cross product property, M times R equals A times B. Okay? So let's try this first one. We're looking for the one that's not true. M times R, M R equals top times that bottom, A times B. Okay, that one is the same, so that's not our answer. Let's try this one. M R equals AB. That's exactly what we did, so that's not our answer. R times M equals A times B. Remember, R times M is the same as M times R, so that's not our answer. So this is the one that's not true. M times B equals A times R. No, that's not the cross product property. We don't multiply straight across. This is not a multiplication problem. Remember, there's an equal sign there. So we have to do top times the bottom equals the top times the bottom. Okay, now we're actually getting into the nitty-gritty here. We're going to do some problems. It may help you, so let's put parentheses when we have more than one term in the top or the bottom of the fraction. It can help us remember what we're going to do here. So 3 times this quantity equals 6 times the denominator over here. So I'm going to write it out. 3 times n plus 4 equals 6 times n plus 10. Remembering to cross before you multiply. Okay? Don't forget to distribute by both terms inside the parentheses. 3 times n plus 3 times 4 equals 6 times n plus 6 times 10. I think I'll subtract 3n from both sides, so I'll have 12 equals 3n plus 60. Now I'm going to subtract 60 from both sides, so I'll have negative 48 equals 3n. And remember, we always save our division for last. Divide both sides by 3. And a negative divided by a positive is a negative. The answer is negative 16. Okay, let's try the next one, B. And you can stop the video right here if you want to try it yourself and see how you do. I'm going to set it up so I cross multiply. 7 times x minus 5 equals 2 times x plus 3. Remembering to distribute by both terms, I get 7x. 7 times negative 5 is negative 35. 2 times x plus 2 times 3. Let's see, I think I'll subtract 2x from both sides of my equation. That's a 2 over here. So I have 5x minus 35 equals 6. Cancels there. Now I'll add 35 to both sides. So I'll have a cancellation, and 5x equals 41 when I add 6 to 35. Lastly, saving my division for last, x equals 41 fifths. And if I want to write that as a decimal, 41 divided by 5, I'll get the nice answer of 8.2. Okay, rewind any of these parts you might have missed, or if I went too fast.